So, first things first, my name's Courtenay. I'm a technical architect and evangelist. I've been a developer for far too many years. First started properly on one of these, before migrating to one of these. Bonus points, if anybody can tell me exactly what model that was. No? B+128. Before moving on to one of these, lovely machines they were. And then full speed ahead. That was a real step forward. Anyway. I'm very, very, very infrequent blogger, but if there is anything on my website that you'd like, well, knock yourselves out, but the tumbleweed goes along quite often. So, inversion of control 101. So I'm not intending this to be, not intending to go too deep. I'm trying to give a general overview, an introduction as to why inversion of control is a technique you should be practicing as part of your day-to-day development. So first things first, who understands what inversion of control actually is? Good. Okay. How many people use dependency injection? Good. Okay. So you all understand what inversion of control is? Oh, sort of. All right. Okay, we'll come on to that. I'm sure we've all seen blocks of code very much like this. We've got a class with a method that's doing some work, and it's using a repository of some form. We've got a reporter of some form, and given a location value that's been passed in, we're getting some results and reporting them out, displaying them via a reporter. Okay. What are the main problems with this? Anyone?
Tightly coupled.
Tightly coupled? Yes. Brilliant.
It's not testable.
Say again?
It's not testable.
It's not testable. No, absolutely isn't testable. So, this we see all the time. So what can we do about it? Or why should we want to do anything about it? Well, testing is the main problem. So it's the class itself, our do work itself, is containing the resources it's using. It's got two dependencies it's using at this point, it's newing them up, it's doing things with them, and it controls them. So it is in control of its dependencies. Yes? So the point that you do work, you, or the do work function, is responsible for getting an instance of the repository, is getting an instance of the reporter, and doing whatever it needs to do with it. Okay? But we can't test this because we don't know what the side effects are. We can't test this because we can't get access to the things that we're calling. Yes? So if we look at it conceptually, we have this thing, this box, this is do work, our method. And do work is being passed a location. So a location object is being passed into it. And internally, it is using a repository and is passing the results of that repository to a reporter. But it's a closed system. I can't get into it. Other than passing in a location, I have no way of testing, I have no way of seeing what's going on inside it. What's more is I have no way of changing it. So when I'm actually running this program, or when I'm using this block of code, it's tightly tied to the implementation of the repository that we've been provided. It's also very tightly coupled to the instance of the reporter. So that reporter could be doing anything. That reporter could be writing to a text file. That reporter could be writing out to console. Even worse, things like the repository could be calling out to a database. So even if I was able to do things with the location, if I was to say, take the attitude that I know that the reporter is going to be writing out to console to write line, and I redirect console to write line, so I redirect where the text writer goes to, so I can pick up the results. and then examine those results, well, I don't even know what the repository is doing. The repository itself could be calling out to a database, and how do I know what state that database is in? How do I know that the testing framework that I'm running is in even has access to that database? Yes? So this is the problem that we're trying to solve. The small bits of code that look simple on the surface, but actually have problems associated with problems stored up with them. Okay? This is very tempting to write code like this, because it's simple. It requires no thought. Pick up dependencies, do something with them, and Bob's your uncle. Everybody with me so far? Anybody disagree with anything I'm saying so far? Cool. I like this. So, one of the solutions for this issue is to go down the route of looking at a service locator. So what is a service locator? So a service locator is simply something that locates your services. So in the respect of I'll do work, here we have our repository and our reporter and their services. The service locator is simply something that we can go to and say, these are the things I want. Okay? So, I don't like doing slides. I think slides are boring. I much prefer to show things in code. So what we have here is a very simple, and what I will say is I will put all of this up on, and that decides it wants to move over. Come on. I will put this all up on GitHub later, so I will tweet the address when it goes up. Okay. So I've got a very simple application here. This is an application. Can you read the code at the back? Can you see this? Yeah? Wonderful. So I have a film repository. The film repository happens to have the top 30 films as voted on IMDb at the moment. I have an instance of a filter. This filter is the since 2000 filter. So I'm just going to filter out any, all I'm interested in is in the top 20, the top 30 films that have been released since the year 2000. And I have a sort strategy. That sort strategy just happens to be in a year order. Okay? So my function just simply does this. It gets the films from the repository. It applies a filter function to those films. I order them, bung them to an array, and then display them. Okay? And as you'd be completely unsurprised to see, there are the lists of the films released since the year 2000 that happen to be in the top 30. And there's a disgustingly large number of films by Christopher Nolan up there and Peter Jackson. Interstellar somehow is in there. I don't understand why. Anyway, so the problem that we have, as we've already seen, is that the dependencies that this method is using are captured, not owned by the method itself. So it means that we don't have any way of testing this. And as I say, as opposed to knowing that that's what we're writing out to the constant write line, and writing a test that redirects where constant write line writes to, there isn't really any simple way of testing this. Okay? So we can make this easier to work with. The easiest way of working with this would be to turn this into a service locator-based application. Okay? So if we're going to have a service locator, what are the two things we're going to need to do with it? What does a service locator need to do?
To identify which service to use.
Right, so we need some way of, given a key, guess to get a service, a class out of it, yes? Right? So that will be that'll be the resolve method. And we obviously therefore need some way of registering. Right? So we're going to need so our service locator is going to need two things. It's going to need a way of registering a type, yes? And it's going to need a way of resolving against that type. Yes? All with me? Okay, so let's say that we have a now when I was packing to come up here, I packed with my proper sculpted wireless keyboard just so that I would have something reasonable to type with. Because as much as I love the Surface Pro 3, the type cover is not a particularly wonderful thing to be working with all day in, day out. Just words to yourself, if you're ever doing this, just remember to bring the dongle with you. There you go. Anyway. So we're going to have two methods. So we're going to have a public static void method, and we're going to register a type. So we'll register T, and we're going to need some way. So what we're going to need to do is say, if we're asked for T, how do we generate something that is that T implements? Or, sorry, that implements T. So what we'll ask for is a function. Okay, and this function will return an object. Okay, so I'm going to register T against a function, and I need to store that somewhere. So let's just have a dictionary. Okay, so we'll have a private static dictionary, and we're just going to register a type as our key. We'll have a function. So there's the function object that we're passing in. Okay, call this service map. As I say, there we go. So when we register, what we're going to do is just put into our service map, given the type of T, and we're going to put in our function. Okay? Easy enough? So, in my application up here, currently I'm saying that I'm sorry. That's my simple app. In my constructor for the simple app, what I'll do, I know this would normally be done somewhere else, but I'm doing it here just so it's easy enough to see. So I'll be saying locator, register. Now, my film repository actually does implement an iFilm repository. I've already done this ahead of time. So I can say my iFilm repository. And the way I'm going to get an iFilm repository is to new up a film repository. Okay? So I've registered the interface, iFilm repository. I've provided a method, a function, that when executed will give me the concrete implementation. Yes? So we can do the same thing again, and say service locator, register, and in this case we've got the iFilm filter, and we'll register that against a new since 2000 filter. And again, last but not least, we'll say our service locator register, and we'll register the iFilm sort strategy against our new instance of the film sort strategy. Okay, so we've got, so our service locator's got these three things implemented. The only thing I now need to be able to do against my service locator is say that I need to resolve. Yes, so given a type, I now want the concrete implementation, given the function that's been passed in. Yes? Okay? So, say it's public static. So it's a static class. Public static T. Resolve T. So this should just be a case now of saying I have a service map, I know type of T, so this is my key. I can execute that, I'll return it, and it'll need to be cast to. There we go. Does that look odd to anyone? Does that make sense? So we're simply looking up from the dictionary, given the type of that we're passing in, we're getting a function out of the dictionary, we're executing the function, we know that at the end's type, right? So if we're asking for an IFOO, we want it to be an IFOO coming back out, so that's what we're casting it to. Okay? So now we should be able to go back to our application here, and as opposed to saying, I want the new film repository, I should now just be able to say, I want the service locator, resolve, iFilm repository. Okay, and again, I've now got the service locator, resolve, and this was the iFilm filter. And last but not least, service locator resolve. By the way, if I make any typos, I'm relying on you guys as my eyeballs to work out what it is I've done wrong, and to let me know. Okay, so we've changed the naive implementation where we encapsulated where we were containing our dependencies within the method, to something that now has the ability to go out to something else and say, resolve the dependencies for me. Plus, we have the ability to be able to set up our dependencies on our own. Yes? Which is nice. So, well, it should come as no surprise, that works. So is there a problem with this?
Really problems.
No.
Actually, there is no control of lifetime, and there is.
We'll come on to that. Okay, well, that's something. Let's ignore lifetime at the moment. This is as it is. Okay, there's no worries about that. Okay, so what we can do is we can write a test. Yes, assuming we're not doing things. I know we're not doing things correctly. We should have done the regular refactor. We're not doing that. But we will write a test. Okay, so we'll add a test class in here, and we'll say this is our app test. Sorry, whoa. Is that big enough? Can you read that at the back?
Yeah.
Good. God, there's much bigger. Anyway, right. So I'm just going to set this up as a test fixture. And hopefully, will I not set that? I thought I'd already set this up as a dependency. I do beg your pardon. Project name. My bad. I thought I'd already set that bit up. So sorry, I'm just only because you won't be able to read that, but I'm just installing any units as a dependency so that we've got something up and running to run a test with, and hopefully nCrunch should then pick this up and take over. There we go. So, why isn't that picking up? That's odd. What have I done wrong here? I can't see it.
Do you want me to be using the, not the using statement for the library?
Yeah,
Should be prompted.
it should be prompted.
Very sharp.
Yeah, exactly. Very unusual for resharpen not to see. Okay. I will come back to that in a second then. So that is, what namespace is that going to be? That's going to be an N unit dot, no. Typical. Never ever run live test, write live code in front of an audience or guaranteed to go wrong.
No, actually, there was a virus running in the background.
Yes, that's all.
So maybe the sharp is getting quiet.
Well, there you go. And it just doesn't seem to be in my no. Visual Studio for some bizarre reason doesn't seem to want to see it, so I'm not even going to bother. Okay. The problem would be, if I can talk through the issue rather than sort of displaying it. The problem is that we need to set up in advance what our dependencies are when we're testing. So imagine when we're looking at this from a testing perspective, we instantiate our simple app class, and when we call run and we're testing it, what's going to happen? No, it won't. It will break. Because we haven't registered. So we would have to register with our service locator any dependencies that we need for the class. Where in the signature for the class or the method do we state what our dependencies are?
It'd be in the creator, wouldn't it? Or a static creator.
No, we don't. We've got nothing. If we're looking at just the signature, right? So just from the signature of the run method, if I was to collapse that down,
Sorry, I thought you
where
meant
does that tell you what your dependencies are?
Sorry, I thought you meant where should we rather than where have we.
No. But the point is it doesn't tell you what the dependencies are. So you've got, yes, precisely. So there is no communication of your dependencies. So okay, so from a test perspective, you should know what your dependencies are because you're writing the test for the class. But if you are the consumer of this class from another, and this is in a library, for example. So, or you're working in you're working in a company where this is one team within the company has produced this class, and you're consuming it from another from another part of the company. How do you know? How do you know that this method now has that dependency? In fact, even worse, what happens when dependencies get added? So currently we have a film repository, a film filter, a film sort strategy. Okay? What if the block at the bottom there, our for each, where we're displaying everything to the console, what if we now have a film writer strategy, where we are writing the results to a file? There is nowhere in this class, there is nowhere in that method that possibly suggests where these dependencies are. Okay? So again, your tests become brittle. Everybody with me so far? I see people nodding. I don't see people shaking their heads. Yeah?
Yes.
Wonderful.
Is your app test in the right?
Say again?
Is your app test.cs in the right project?
Apptest.cs is in the right project. Yeah, I know. It's in the right project, and there is an unit, and there is mock queue, and everything else. And quite why it's not seeing that dependency, I have no idea.
Sometimes restarting Vision Studio.
Try turning it off and on again. I could do, I suppose. Yeah, let's quickly do that. Don't you just love technology? nearly there, it's nearly bedtime. Okay, so if this doesn't work, I'm not going to worry about it. So, test fixed. It's thinking about something. Yay! Ah, wonderful. Right, so, okay, so the static void, so what have we got? If we just say something along the lines of run should use whatever you, so run should get films. It's an easy enough thing to demonstrate. So, as I say, as a consumer, so notice that green box up there, that's saying crunch running. So as a consumer, I can get the system under test, I can new that up, and that'll be my simple app. Okay, that is going to need, my test project needs a reference. Where are we? References. Add reference to that. Okay, so should now see it. Why did it say that? This is internal and it's public. Go. That's it. Right, it's all coming into play now. So I can new it up properly, and as a consumer, I've looked and I can see there is a run method, and that, for some reason. Yes, of course, because I've done the thing I shouldn't have done, which I was shortcutting for this demo. If I had done the registration outside of the class, like I should have done in my application overall, the start name fails. And of course it fails because I don't have any registration set up in my service locator. So my service locator is now this magic global thing that has the knowledge of how to resolve. What's worse is that if I'm doing everything in a library that's being passed around, this service locator is now hidden inside my library. So the consumer of my class not only needs to know that he has to set up a service locator, he has to set up the exact service locator that I'm talking to, right? Unless, of course, I now take the service locator and pass that as a dependency to my class. So that is a way of resolving the problem. So I could say that I have a service locator that implements iService locator and pass that in as dependency. But even so, even if I do that, I still don't have anything on the surface of that class that says what its dependencies are. Okay? Brilliant. So, let's quickly dive back to the slides. So, everybody happy with that so far, yes? So, our service locator, as we say, is a foo uses a locator, and that locator will locate bar or baz, depending on what it's been asked for, and depending on what its registrations are. So, specifically, issues include, and are not limited to, but the big ones are that you can tie code to specific locator implementations. So, as I say, that class knows how to get its dependencies, but it only knows how to get it from that instance of a service locator. Yeah? And it hides the class dependency. So, as I say, here's an example of the service locator. It's pretty much what we've just done, except that in this case, to get around the idea of there being a global service locator, here's the idea that we're passing it in as a dependency to the class itself. So is this bad? Well, again, yes it is, because again, it's tying it to the idea that the class itself has to go and get has to go and get the things it needs to work with. And it still requires, as I say, it still doesn't show what it's using. Okay, and this is again the same idea, but this is using the search locator as a global. So the way around this is to think about dependency injection. So as opposed to saying, I have a class, I'm going to go and get the things I need to work. How about the class itself is given the things it needs to work? So those things are taken out of the scope of what the class needs to do. The code can then concentrate on precisely what it needs to do for its work. Does it need to know where these dependencies come from? Well, most of the time, no. What it needs to know is that it has the component parts required to fulfill the work it's asked to do. Yes? So one way of doing this is with a container of some form. And the container creates the objects on your behalf. So in this case, the simple app would be created by the container. So foo is created by the container. And foo has its dependencies, in this case, we'll express them on its constructor. And the foo has in its signature, in its constructor, it takes an instance of iBar. Doesn't know what iBar, it doesn't know what the concrete implementation is, but it knows it needs an iBar. And so the container has a registration that says, when asked for an iBar, give it this concrete implementation, which you can then inject into foo. Any questions on that? Does that make sense?
It does. Can I just ask one question? 'Cause it seems like you skipped 2 steps there, but I want you this is very shaky.
Fine.
Could you have done this with just normal constructors? As in, could you require everyone who creates a foo to pass in a bar rather than make the container
Yes.
create the bar?
Absolutely.
No.
Absolutely. I'll come on to that.
Okay, great.
I'll come on to that. Because this is the Hollywood principle. This is the don't call us, we'll call you. And one of there is it's sometimes known as poor man's DI, but in effect it's pure DI. So this is a perfectly valid dependency injecting piece of code. Yes. So in this case, I have I have a class called dependency injection example. It takes a repository. The repository itself, to build the repository, takes a file locator, takes a credential store, and a settings manager. It also takes a reporter, which requires a console writer and a settings manager. So that is the container. This is the container that just happens to build the dependencies for you, right? So the registration is purely code. Does that answer your question?
Yeah.
Right. So that is dependency injection. So where was I? Yes. So you can two main ways of achieving your dependency injection would be to either construct the dependencies via the constructor, or you sometimes see in some frameworks that they like to do things by injection. Now, I'm not saying this is the wrong way of doing things. I have a personal dislike for this mechanism, and the personal dislike is that you can trawl through the code and you can see where the injection points are. In this case, in the C# frameworks, I've seen this done, and they tend to be done with an attribute that decorates the setter. Okay. The reason I don't like this is it doesn't tell you when this happens. This happens at some magical point before, hopefully, before you execute your code. There are lots of frameworks that do this by default. I mean, Spring in Java world is, you know, the main pattern is to do this by is setter injection. I'm not a huge fan, I'll admit. So this is my first.
Would that be what's necessary to actually?
Yes. So this is my preferred pattern because it's obvious. When you new up, you can either new up via a container or you new up manually, your dependencies are there. You can't get this wrong. You can't get your poor man's DI wrong with this because they are required. You can't instantiate the class without the dependencies being there. Does that make sense? So as I say, that may be referred to as poor man's DI. I've sometimes heard this as bastard DI as well. It isn't actually. For a lot of cases, there is no reason to use an injection container for large sets of applications. A container is overkill. The problem you tend to find, though, is that especially when your application becomes of a certain size, that becomes very difficult to maintain. It becomes a soup of constructors. And also when you're dealing with lifetimes or you want to share instances, it can become very convoluted. So it takes one half dozen the other. But that is, in essence, a dependency injection container. But we'll write a proper one. Well, I say proper one. We'll write one that actually allows you to do a bit more than that. So, what is our container going to need to do? What two things is our container going to need to do?
Register and resolve.
Well, it's not far off the service locator, actually.
Identify which concurrent class should be initiated.
Right.
For which interface.
Yes.
Uh,
So we're going to have two things. We're going to have a
Register.
resolve. So we're going to register. So we'll register a concrete, a base class or an interface and a concrete, and we need to resolve. Yes. Okay. So let's do that. So let's go back to our simple app. Ready. So first things first, I'm going to change the simple app so that the repository, the filter, and the films, the sort strategy are now constructor injected dependencies. So I'm going to just quickly do this. Whoops. So that's implicit, explicit, I think. And go. Got some lovely sharper. It does make this so much easier. Okay, so I'm just going to turn these into fields, and then I'm going to initialize these fields from the constructor. I'll just let ReSharp just do this for me because it's so much faster than I am. Okay, and there we go. I'll just initialize field from the constructor. So moaning about these is probably because, yeah, they need to be made public. Okay. So I now have my class is set up so that I have the three dependencies that it needs, and they are the repository, the filter, and the strategy. So nothing has changed really, except that you can now look at the constructor and it's now immediately obvious what the class itself needs needs to work. Yes? So if I was to use poor man's DI at this point, I could simply new it up and provide the concrete instances in the constructor by hand. Yeah? Okay. But we're not going to do that because that's way too easy. So if I go back to my application, so I have a program class. There's my program class. So obviously this is now not going to work because this program class is now asking to new up a simple app, and the simple app has no constructors. So let's say that what we'll do is we'll get a let's make a new container. So if our container equals new container. So what are we going to need to do? We're going to need to have some way of registering, yes? So we'll say container register, and we'll say that our film repository will map to our concrete film repository. Okay? Simple enough. And additionally, we've got our film filter, and we have our film, what else have we got? That's the one. So, and that's our since 2000 photo. Okay, so we've got enough to get started with. And our simple app will come, if we say, in fact, if we do this, so it's explicit, right. So we can now say that we want this to be container, and we're going to resolve the simple app. Okay? So we're not even going to bother registering simple app. Simple app is a concrete class, and we know it's there. We're just going to get it resolve all our dependencies for us. Yeah? It's a simple API, but it's working. So we need two things. We need our register. So our container. It is obviously picked up from somewhere else. Hang on. Yeah, I picked up components before we want that. Thought it was a bit quiet. Right. Where No, stop it. Stop it. Right. Creative. Thank you. So there's our class. Right, so we want, there's one method. So, we register a base type, and we get our implementation. Okay? So it's like this, it's horrible. And we need a way to resolve. Okay, brilliant. So, anybody worried by this so far? No? It's all fairly obvious. Good. So I'm just going to delegate this out to, so let's call register, because I've done this a few times practicing, so right. So type of T-base, type of implementation, T implementation. Thank you. Somebody's paying attention. Okay, so and we'll just simply say public void just type. Okay, so we've got a nice generic way of registering, but we've also got a way of doing against straight types. Base type and type implementation type. Okay, so much like the service locator, we need some way of holding these registrations. So the easiest way of doing this is just going to have a dictionary. Yeah. So again, we'll just say that we have a private dictionary, and it'll be type to type. Okay, so our type map, say this in the dictionary. And so our registration is nothing more than adding a base type key to a information type value. Go is equal to implementation type. Okay? Easy? So when we register iFoo against foo, we're saying that we want this to be registered. But the crucial difference, here, if you remember the service locator, I registered a function. So I registered the method by which I wanted this to be created. This, I'm just simply registering type. Okay? Because I want to do the introspection myself. So, when I resolve, what do I want to do? Okay. Say again?
Return item from dictionary based on the
Okay, but that's a type. So, from the dictionary I can get, so I can say, so what I'm going to do, first things first, I'm going to back this off against a straight object version. All right, so I'm going to return resolve type of T. So this will simply be public object. Can't type. Okay. So this is the base type that I'm resolving. And so that needs to be cast to. There we go. Right, now why have I done this? Because. So, if we have, and I apologise to Jules if he was watching, if anybody was at Jules' Maze talk, if so, evil. So, if we have the type in our dictionary, then I want to construct the type from my dictionary. Otherwise, I'm just going to simply construct the type itself. Okay? So, our simple app, we're not going to have in our dictionary because we're not registering it. We're registering all the interfaces, but we haven't registered the simple app. So, in that case, I'm simply going to create that type from scratch, right? Otherwise, I want to transpose to the type that I'm asking for, right? So, if our type map contains key base type, then we'll return and we will create instance of our base type. Otherwise, we will return create instance of, in this case we want to create instance of from the type map base type. Otherwise, we simply want to return this. Okay? Now, what we're going to do at this point is I'm going to go to the type and I'm going to look for the constructor. But what I'm going to do is I'm going to look for the constructor. Generally, by convention, what we tend to do is we tend to go for the most explicit constructor. So I'm going to look for the constructor with the most number of parameters. Yes? So if I get base type, so base type dot get constructors. Order by descending, and I'll just say info dot get parameters count. Okay. First default. First, actually, I'm not. I'm going to have. There is no error checking this at all. All right, so please don't shoot me. And there we go. So, well, constructor. So, so we've now got the constructor for the type that we've been asked for, and we've got the most explicit constructor that there is, assuming that there is only one with X number of parameters. Okay. Now, what we want to do is we want to fill in those. We want to fill in those values. So the easiest way of doing this is to go to the constructor, get parameters, and then I'm going to select. So each one of these parameters is going to have a parameter info in it, right? So if I select the info, and I then resolve the info dot parameter type to array, that is going to give me spelled it right, I know. So, we've taken the constructor, we've walked through every one of the parameters, and so in the case of the simple app, our parameters is going to be three of them. It'll be iFilm repository, iFilm filter, iFilm sort strategy in order, and I'm passing them back through the same method to resolve. So recursively go back through and resolve. Once I have that array, I can now constructor invoke, given the parameters, I'll just simply return that. So, invoking so I have the parameters, I've filled them in, passed them back into the parameter, passed them back into the constructor and injected it, and that will now work right way down the chain. So every time I get a dependency, it will resolve, it'll fill it in, it'll look at that dependency and go, what are the parameters? Are there any parameters? Resolve each one in turn, and so on and so on and so on, until it completes, and then come back up. So, unless I've done something stupidly wrong, which I wouldn't put it past me, that should, fingers crossed, run. Yes, first time. There you have it. That is a dependency injection container written from scratch in a few minutes' time. That didn't take very long. The reason I did that was not to say I'm wonderful. It was to say this stuff is simple. There is nothing to it. The principle behind what's going on here is very, very easy. So why wouldn't you use this in a production environment?
Because the reflection would be horribly slow.
There is that. Well, no, actually, no. At what point does the reflection become important?
When it's being created. So if you were creating something a number of times.
Okay. So one of the features of your code when you write it from this perspective is everything gets generated up front. So your injection happens early on. So your startup might be slightly slower. But once things are up and running, actually everything has been resolved for you. Right? But the time you actually execute the do work in the simple app, by the time I actually execute run, all the dependencies have been set up. They're already there. So unlike the original version of run, where I'd executed and it would new up the objects every time, right? So if you go back to the original version of this, it would new up the film repository, the filter, and everything else every single time. In this case, it doesn't. And also, think back through your code. How often do you actually need to get new instances of your objects? Think of a web application, right? Once you have your configuration, for example, if you've got say you've got a configuration system that needs to go off to a third party, gets go to a console IO or something like that to get its configuration, calculate things calculate values. Once that's done, it never needs to be done again, right? Any class that gets given that as a dependency, it's done. It's there, it's baked in. Yes. So it does change the location of where these things happen. The reflection actually isn't that bad. It's not that bad, really.
One thing.
Yes.
Sorry, one thing I don't quite understand is,
Sure.
won't you find it difficult to maintain any sort of state? So, for example, if the simple app needed some settings that had to be read from a database,
Yes.
instead of reading that once and then injecting the settings interface into all the things that need it,
Yes.
every time you create a simple app or any other object that needs settings, it will have to generate a fresh settings class reading
Right.
straight from the database.
So that's why you don't use this implementation, because this
Right.
implementation is seriously naive. It's not doing it. It's not holding on to any. You're right. Every time, in every interface it's going down, it's resolving every single time. That's why you would tend to use something that's been done properly. So if you use something like structure map or Ninject or custom window or any proper DI container, you could specify the lifetime of an object. So you could say that you want to, so I could extend my registration mechanism to say that I want to register in transient scope, or I want to register in singleton scope, right?
Yeah.
So what I could say is that, so for example, let's say I do a singleton registration at this point. So if I was to say my container that I'm going to have a scoping on, right? And by default, I'm going to say the scope is going to be transient. So every time somebody asks me for an instance of an IFU,
Yeah.
right, is going to get me a brand new instance,
Right.
right?
Yeah.
Or I could say I want a singleton version,
Yeah.
right? And what we'll say is that the implementation here, let's say, I don't know, scope equals scope dot transient, so on and so forth. I won't bother going through this full thing, but you can see what I mean. What I could do is I could resolve it. If the registration is marked as being singleton, I could then store that object in another dictionary,
Yeah.
and hand that instance out every time it's asked for.
Okay.
Yes.
Yeah.
So one of the reasons, so for example, if you're using something like Ninject, which other ISC containers are available, it's just the one I like to use. That they have this full idea of scoping, and if you're running in a web application, you can register in request scope, for example. So you can have an object that's defined, if it's asked for during a request, an instance is created and held onto. So every other time it's asked for during a request, it's given the same object is delivered back.
Yeah.
Okay. So that's the reason why you wouldn't use this version. This version is seriously naive. So yes. This does also lead on to that does also lead on to a small extra problem, which is to do with life cycle. You do sometimes have to be aware from the container perspective what life cycle you're dealing with. So, for example, if you were to say that you were injecting something with transient life cycle into a singleton, so an object with singleton life cycle, it's going to capture the transient life cycle.
Right.
Do you see what I mean?
Yeah.
In which case you may need to consider going out to a factory. So you would inject a factory to get that to get that time. But at all times, the idea is don't tell the class how it gets its dependency or where the registration is or anything else like that. You let the system handle it for you. Does that make sense?
I think so, yeah.
Okay. Any other questions?
You mentioned low inject.
Yes.
Unity, we're still using.
Yes, Unity is
that there.
exactly the same.
Fine.
Exactly the same. I mean, the principle for all of these systems is the same. I mean, it boils down to there is a mechanism for registrations, and there is a mechanism for pulling these things back out. Unity has a very XML-based registration system if you want to use it that way. I think it has got the code interface as well.
Yeah.
But
Fluent APIs.
there is a fluent API, that's right. I haven't looked at Unity for a while. Years ago I was using it and the XML scared me off, so I didn't come back. Any other questions? Are you all that desperate for beer? Surely there's one or two questions we can go. Yes, there's a hand at the back.
I might be being a bit thick, but I still don't see what the advantages are over just passing it to an instructor, an interface for your repositories, and even managing the life cycle of repositories within the class somewhere. What really is a container giving you on top of just passing it?
As I said before, there is no reason not to use pure DI. If you want to use pure DI, please. It's great. And just the act of using pure DI or setting your application up that way solves entire swathes of problems. Right? So it is, you do not have to use a container by any stretch of the imagination. Where it does become useful is, as I say, when your application reaches a certain size, you very quickly find that by doing the registration at your composition route manually, that it becomes unwieldy, and it's very easy to get lost in the noise, and especially if you have something that is where you are using the same object over and over again, right? So in your class hierarchy, you're reusing the settings. Yeah, so you've resolved a settings class. Yes, you're passing that into everything. It becomes very, very, very quick to lose that in the noise. Do you see what I mean?
I do, but then for the sake of clarity, essentially you're putting into a global space. But for the sake of clarity, I've sort of always been taught that if you're using it somewhere,
yes,
you pass it in. So if you've got a config object, you need to pass into various things. You would pass in your by config into the constructor. And your constructors might get quite large, but I still.
Yeah,
it seems
as I say, that is still inversion of control. That is still dependency injection. It is. There's just no two ways about it. Containers will help you containers can help containers could help you provide configuration or setup at runtime, for example. You may have it set up so that you've got configuration for your container is held external to the application. It might be an XML, might be an external resource. In which case, setting up manually is not going to help you, or it might make lifecycle more difficult. Also, dealing with lifecycle scope in situations where scope is important is a godsend. So, I mean, I deal with highly available, very fast response websites. Knowing that side of things is dealt with for me, it just allows me to concentrate on other things. Okay, but it's not a panacea. Don't just drop everything to bunk container. Does that help at all?
Yeah.
Yes.
So we now take this into the testing scenario.
Yes.
The code which you've got in your main,
Yes.
which does the registration,
Yes.
that goes into your initialization type method.
Yes.
Yeah.
Absolutely. That is the composition route.
Obviously, you've got to have some sort of access to the container that the application is going to use.
No. Because
The reflection will do it for you.
reflection does it for me. At the entry point of the application, we're now in interfaces. So everything that's testable is now exposed. It doesn't have to be interfaces. The type mappings
You can always pass in.
can always pass in concretes.
Pass in the original.
Yeah, absolutely. You don't have to say I need an interface implementation. You could say I want to register myself. And in fact, because of course, if you go back to the container there, we're doing exactly that. We're simply saying if something's set up, use that mapping. Otherwise use it straight type. But it's the idea of being able to simply walk down a tree and just being able to pick up a type and just run with it. Yeah. And of course, it now means I can change the application. I can change the way the application works, and all I have to do is change the registration. So I can add a completely new filter at this point. I can say that I want to filter by, I don't know, all films that weren't directed by Christopher Nolan. I like Christopher Nolan, but I could do that. The only place I would ever need to make the change is in the setting, to where I'm binding the registration, and that's again where over the manual composition, that's where that is also where the sorry, I can't get my words in. That is also where a container can help. Yes, so if you are changing registration, you're supposed to have to walk through the mess of dependencies. You would change the one registration, and everywhere that's used is already handled for you. But it's not the be all and end all. And the tools like Resharpen will help you doing pure DI anyway. So even if you do nothing else, even if you don't use a container, if you do one thing from this and you use Courtenay's DI, I've won. In fact, you've all won, because in the long run, it makes your code easier to maintain. Yes.
Can you show us I don't think you wrote it actually, but what the test looks like?
Well,
So,
yeah. So,
because the main aim of this was to make the code more testable.
well, absolutely. So, I mean, yes, I can now. So, in this case now, I don't have. This now doesn't compile, right? Because simple app now requires its inputs.
Yeah.
So I now specifically have to deal with this, right? So in which case I would probably be going down the route of saying that I need to set up. I'd be setting up mock instances to deal with, right? So I don't know.
So there are two ways. So if you're using Courtenay DI, you do one thing, and if you're using Inject or something,
I would still do the tests. The tests are identical.
that's right.
The tests are identical. Because the test has nothing to do with the DI with the DI
It's the
container.
test that specifies what
Precisely.
type you get for each,
Precisely.
for each interface that
Yes.
simple app
Yes.
Okay.
Okay. You can even use specialized versions of the DI container for testing. So I mean, I've used in complex setups a DI container that will, if no registrations are provided, will provide a mock, and then you can pick the mock up. So the class is automatically instantiated for you, and you just go back to the container and say, give me the mock of this type. Also mocking containers. So yes, I mean I can go ahead and write it if you like, but the point is that the point is that I would need to provide So I need to provide a mock of the various types I'm dealing with. So in this case, it was the film repository. Yeah. Sorry. Mock of film repository. And of course, I can then set that up any way I want to. Yes.
Yeah, that was the question really. Would you use your DI container in the test at all? That was involved, or how do you do it if you use your DI?
Yes. So yes, absolutely. From a test perspective, I would tend to use Paul Mann's DI. So even if I'm using a container,
Yeah.
the test will be written from a Paul Mann's DI perspective, generally, except in some circumstances where I have sometimes used, or do sometimes use, especially where things are fluid and things will change more often, where it needs to do lots of setups against the dependencies that get passed in. Okay. Any other questions?
So how would you order the incentives, the advantages of using a DI container? I mean, if I'm asking for 3 reasons, why would I be using a DI container in terms of all?
Okay. So the advantages. I think the main advantage is maintainability. Seriously. I just think it just helps in practice. It just helps to make your code base more maintainable.
You see late binding as well, the ability to provide.
You could late bind as well. I mean, but lots of frameworks.
Would you bind the list, or is that should
No,
be
not
a
really.
motivation?
Not really. It's the thing you're trying to drive at is code that's testable, it's code that's open, and you're not binding to a tight implementation. So you're not tightly coupling in code, you're not tightly coupling, and you're not replacing one tight coupling for a tight coupling against a service locator, for example. Yes. Everything else around it is frankly, it's puffery. But the advantages are there. And the other big one is where you, as I say, where you need to where you need to deal with life cycles, especially things like web apps. I think generally web apps especially, because you do generally tend to have two different classes of dependencies. You'll have dependencies that are singletons. So things that once up and running are the same no matter who's making a request against the website. So settings, access to databases, or various things like that. They will tend to be immutable, right? But then you'll have very specific requirements for the request itself that comes in.
So if you see maintainability as a big advantage there, so if I'm writing a small application,
Yeah.
but I don't actually foresee how big it will get in the future.
Start with Paul Mann's.
Sorry?
Start with Paul Mann's DI.
You would actually
Start with
deploy
Paul Mann's
it
DI.
with
Absolutely.
a container.
Well, you need your container is the point that you do the initial, you new up the top level object. Your composition root, the point that your application enters, right? The point that your simple application starts. That's your composition root. Start with Paul Mann's DI, well, pure DI. If that becomes unmaintainable, if that becomes unwieldy, change, but put a container in. But none of your tests will change. None of your tests will change because the tests will look the same. Everything else still stays the same. Okay? I think it's time for a beer. Thank you very much for your attention. And,